Friends, today we will solve a numerical from projectile motion which came in Siemens 2013. So in the numerical, the initial velocity of a projectile is given and we have to find out the equation of the trajectory of the projectile motion. So before solving this problem, we will derive the corresponding formula. So let's consider an object is projected with an initial velocity v0 and angle of projection theta from a point O. Now we know that every vector quantity can be resolved into two mutually perpendicular components. So the initial velocity also can be resolved into two mutual perpendicular components, and the horizontal component is v0 cos theta and the vertical component is v0 sin theta. And we considered a 2D Cartesian coordinate which have the origin at the point of projection, that is O. Now let's, after time interval t, the particle reached a point P which have the coordinate x comma y, which means that after time t the particle have displacement y in vertical direction and x in horizontal direction. So now we have to find out the equation of x and y. After that we have to find out the relation between x and y. So as we know that in the x direction there is no force because gravity is perpendicular to the x direction, that is horizontal direction, and we are ignoring here all the forces due to friction of air. So x will be simply velocity into time, but in the y direction the motion is retarded because there is a deacceleration which is equal to g, and g means acceleration due to gravity. So y will be v0 sin theta t minus half of g t square. So now both this equation have a common parameter t. So we will replace t by x in the equation 2. So now if we put this value of t here, we will get what? We will get v0 sin theta into x by v0 cos theta minus half of g x by v0 cos theta whole square. So y will become what? X tan theta and minus g x square by 2 v0 square cos square theta. So this is the equation of the trajectory of a projectile motion. Now we know that the initial velocity can be written as v0 cos theta I cap plus v0 sin theta j cap, and in the given question the value of v0 is given as I cap plus 2 j cap. So the coefficient of I cap is 1, which is equal to v0 cos theta, and coefficient of j cap is 2, which is equal to v0 sin theta. Now if we divide v0 sin theta by v0 cos theta, we will get tan theta. So tan theta will be 2 by 1, that is 2, and v0 cos theta is 1. So if we put this value in the equation of the trajectory, we will get 2x minus 10 into x square, because g have the value 10 meter per second square. So 2 into whole square of 1. So y will be 2x minus 5x square. So in the given numerical, the option B will be correct. Thank you, friends. So if you find this channel is helpful for your preparation, please like and subscribe.